All right, so today we're going to talk about covalent compounds. So I've done a series of videos talking about ionic compounds, so now it's time to move forward into covalent. So just as a reminder, we've got two types of chemical bonds. We've got ionic and covalent. Ionic is when electrons were transferred, so somebody steals, somebody gives away. And that causes an imbalance in charges, and then we write them as electrically neutral. What we're going to focus on for this video and the next is covalent bonding. So that will be the sharing of electrons to get these stable electron arrangements. If we are sharing electrons, we do not have to worry about charges any longer, but valence electrons are still very important. Lewis structures are also going to be very important to this chapter. In a Lewis structure, what we do is we represent the valence electrons as dots. With ionic, we got lots and lots of practice at identifying valence electrons quickly. So now that we're going to start writing Lewis structures, it'll be a little bit easier now that we can quickly identify valence electrons. So what we see here is a Lewis structure for oxygen. So here's the electron arrangement for oxygen. So 2, 6. And remember, 6 is that highest energy level, or 6 is that top bookshelf. So there's 6 books in the top bookshelf, 6 valence electrons. The quick way that we were able to identify that is by looking at the periodic table, noticing that oxygen is in 16 or 6A, and that also tells me very quickly that there's 6 valence electrons. To do a Lewis structure, what we're going to do is imagine an imaginary box around our chemical symbol. So we write the chemical symbol for oxygen, and we pretend like there's an imaginary box around that oxygen. On each side of the box, we can put up to 2 valence electrons until we've given all of them a home. So for example, here, oxygen has 6 valence electrons. So I could do something like 1, 2, 3, 4, 5, 6. So there's my 6 valence electrons around that imaginary box. You could also pair up those last 2 instead of drawing them separate. So I could say 1, 2, 3, 4, 5, and 6, and leave one side of the box empty. That's fine. I don't really care how you put them around there, as long as there's 6 valence electrons around that oxygen. So that's the introduction to Lewis structures there. Remember also the rule that's going to dictate all of our chemical bonding, so covalent and ionic, is going to be the Octet Rule. So the Octet Rule is having 8 electrons in the valence shell, or 8 books in the top bookshelf. So for neon is one of those that has 8 valence electrons already. So why don't you take a moment to see if you can draw the Lewis dot structure for neon. Okay, so we would draw the chemical symbol. So the chemical symbol for neon is Ne. That we would put 2 dots on each side of our imaginary box until we get to 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's the Lewis structure for neon. You're going to get sick of drawing dots. So I don't really care what you put around that chemical symbol. You can put dots, you can put X's, you can put smiley faces or sailboats, whatever you want to do. Just make sure there's 8 of something around each atom when you're done with the covalent bonding. Just a reminder of the octet there. Covalent bonding. So remember, covalent bonding is between a metal and a non-metal and another non-metal. That's how we identify it as covalent. Once we've identified 2 non-metals, we then will identify it as covalent, and they're going to share electrons. What I'm going to do now is I'm going to go through an example of how we do Lewis structures to depict this sharing of electrons. And then what I will have is a list of rules or the thought process that I went through. But there's really no better way to do Lewis structures than to just dive in head first. So I'm going to dive in head first to an example for you. So the example that we're going to look at is going to be water. H2O, so this guy up here. So the first step to covalent bonding, or to drawing Lewis structures for covalent bonding, is to determine how many valence electrons were brought to the party. So we're going to take each individual atom and we're going to write down how many valence electrons they're bringing with them. So hydrogen, what you'll notice about hydrogen is it is in group 1A. So it will bring 1 valence electron to the party. I notice here with this subscript that there's a total of 2 hydrogens. So I'm going to write my additional atom of hydrogen, and he also brings 1 valence electron. Then I'm going to look at oxygen, and oxygen is in 16 or 6A. So he's going to bring 6 valence electrons to the party. So if I add up all of the valence electrons, I have 8 valence electrons at my disposal at the party. I have 8 valence electrons to use in a bond. The next step is going to be just to throw some sort of skeletal structure on the paper. Chemistry is very symmetrical. So here I see 1 atom of oxygen and I see 2 hydrogens. So likely the oxygen is going to be in the middle, and I'm going to have a hydrogen that flanks on either side of it. If there was 3 hydrogens, probably 3 around that central oxygen. 4 hydrogens, 4 around the central oxygen. So just think a very symmetrical, balanced approach. So skeletal structures on the paper. Now I'm going to start distributing or giving away those valence electrons to make everybody happy, to fill octets. Before I do that, I want to talk about one exception to the rule. All right, so one exception to the octet rule, and that is hydrogen. Hydrogen is actually happy with what we call a duet. So hydrogen is okay with just 2 valence electrons. So when I go to do these Lewis structures, hydrogen only needs to touch or only needs to have 2 valence electrons at his disposal. All right, so distributing valence electrons to make everybody happy, I have 8 to distribute. So I'm going to put 2 right here between hydrogen and oxygen. So these 2 atoms are sharing those 2 electrons. So that's 2 out of my 8. And I'm going to put another 2 between this hydrogen and oxygen. So these 2 guys are sharing these 2 electrons. That satisfies both of those hydrogens. So, for example, this hydrogen is touching these two electrons. He's happy. This hydrogen is touching these two electrons, and he's happy. So I don't have to do anything else to the electrons, or excuse me, to the hydrogens. This oxygen, however, is not finished. He doesn't have 8. So I've distributed 1, 2, 3, 4 electrons, and I have 4 more to find a home for. So I'm going to put 5, 6, 7, and 8. So that's the first thing, is I've distributed all 8 electrons that were brought to the party. All of them are on the paper. So that's an important step. Now I need to go back and make sure that everybody is happy. Everybody has an octet or a duet. So let's look first at hydrogen. Hydrogen is happy with a duet. So hydrogen has how many electrons? 1, 2. So that hydrogen is happy. This hydrogen over here, how many electrons is he touching? He's touching 1, 2. He's okay with a duet, so he's happy. And this oxygen in the middle is touching how many electrons? He's touching 1, 2, 3, 4, 5, 6, 7, 8. So he's got an octet and he is happy. Yes, I draw smiley faces on my atoms. Go ahead and get used to it. So here we have distributed all of our electrons. We went back to double check that everybody was happy. Everybody is happy. Their valence shell is full. They have stable configurations. So this is the Lewis structure for water. Okay. Before I dive into the steps, I want to just get a little bit of terminology out of the way so that we can use it in our examples moving forward. So here you see again the Lewis structure for water. We've got 2 different types of pairs that we need to talk about. The first is a bonding pair. These are going to be electrons that are shared between 2 atoms. So here's a bonding pair between hydrogen and oxygen. Here's another bonding pair between hydrogen and oxygen. So these would be electrons that 2 different atoms are touching. A lone pair is going to be non-bonding. So they belong to only one atom. So again, oxygen here is our middle atom. He's got 1 lone pair on the top, and he's got a second lone pair on the bottom. So nobody else is touching those electrons. They belong to just him. So that's a lone pair. We are lazy chemists, right? So very often, instead of drawing bonding pairs as dots, very often you will see chemists draw bonding pairs as lines. So this line right here represents 2 electrons that are being shared. It represents a bonding pair. Same thing with this line. So the important thing to keep in mind here is when you count electrons, make sure that when you touch a line, you count 2. So I would count 1, 2, 3, 4, 5, 6, 7, 8. So each line represents 2 electrons. All right, so here's the steps that I followed for writing Lewis structures written out into words for you guys to see. Underneath each step is going to be some helpful hints or little tools that we can use. Likely at this point, we won't be able to use any of those just yet. We've got to get some more experience under our belts, but they're there for you to refer back to as you start to get more proficient. So step 1, calculate the total number of electrons. So determine how many valence electrons each atom brings to the party and total those up. Step 2, write the correct skeletal structure. So put the atoms on the paper in some sort of symmetrical approach. The other hint here, we've actually have seen this one, hydrogens will always be terminal. So what I mean here is you would never find a hydrogen in the middle like this. Why will a hydrogen never be in the middle? Well, this is 1, 2, 3, 4 electrons. Hydrogen only wants 2. So that's why hydrogens will always be terminal, or they'll always be on the outside. So symmetrical, hydrogens on the outside. Step 3, distribute electrons, filling as many octets as possible. So this is where we start to just move around the atoms and put dots to make everybody happy, and just making sure we distribute all of the electrons that we have. And step 4, we're not here yet, but I went ahead and included it. If we distribute all of the electrons and somebody is still not happy, somebody lacks an octet, if and only if that happens, then you can explore double and triple bonds. So we'll get to examples of that very shortly, but I threw it in there right now. So let's do another example. I want you guys to see if you can draw the Lewis structure for chlorine, for Cl2. So pause the video, write the Lewis structure, then I'll walk you through it. So, step 1, calculate the total number of valence electrons. So each atom of chlorine brings with it 7 valence electrons. And I see that there are 2 atoms of chlorine. So 7 valence electrons times 2 gives me 14 valence electrons at the party. Step 2, write the correct skeletal structure. Well, this one's pretty easy. They're right next to each other. There's really no other way to draw them. Step 3, distribute electrons, filling as many octets as possible. I always start with a bonding pair. So I will always start by connecting atoms together. And then from there, I'll start distributing lone pairs of electrons. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I have to stop because I have 14 electrons at the party. I've put 14 electrons on the paper, so I cannot put any more on the paper. I don't have any more to put on the paper. So I've distributed 14 electrons. Now I need to make sure that everybody's happy. Make sure everybody's got an octet. So I'm going to go back and look at how many electrons they're touching. So this chlorine here on the left has 1, 2, 3, 4, 5, 6, 7, 8. So he has 8 electrons. He's happy. And this chlorine on the right has 1, 2, 3, 4, 5, 6, 7, 8. So he also has 8. He is happy. This is the correct Lewis structure for Cl2. Let's do another example. So pause the video and draw the Lewis structure for O2. O2. First thing you're going to do is determine how many valence electrons were brought to the party. So again, oxygen brings 6 valence electrons. There are 2 atoms of oxygen, so I have 12 valence electrons at the party. Step 2, draw the correct skeletal structure. Again, there's 2 atoms, so they're right next to each other. All right, step 3, distribute electrons, filling as many octets as possible. So what I'm going to do now is I'm going to draw a bonding pair. So that's where I always start. And then from there, I'm going to distribute my remaining electrons as lone pairs. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have to stop because I don't have any more electrons to put on the paper. But what do you notice about this Lewis structure? Well, this oxygen on the left here is happy, right? He's got 1, 2, 3, 4, 5, 6, 7, 8. So he's got an octet. He's happy. But what about this oxygen on the right? He's got 1, 2, 3, 4, 5, 6. So he is not happy. It's not going to work for him. I don't have any more electrons to distribute, so I can't just give him 2 more electrons. So how could I make both of these guys happy with what I have on the paper? Well, if you noticed the title of this slide, it's double and triple bonds. So atoms can share more than 2 electrons. So what's going to happen in this case is instead of just sharing 2 electrons, these oxygens are going to share 4 electrons. So you're going to take a lone pair away from somebody that's happy and throw them into this bond. So instead of sharing 2 electrons, they are sharing 4 electrons. Okay? So now let's go back and check and make sure everybody's happy and make sure we've followed all of the rules. So first thing to double check after you've moved some electrons around is to make sure you still only have 12 on the paper. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So good news is I still have 12 electrons on the paper. Now I need to see if everybody's happy. So if I look at this oxygen on the left, he's got 1, 2, 3, 4, 5, 6, 7, 8. So he's still got 8 electrons. He's still happy. And now this guy on the right has 1, 2, 3, 4, 5, 6, 7, 8. So now he is happy. So this is the Lewis structure for O2, and it does involve a double bond. So a double bond is the sharing of 4 electrons instead of just 2. So here's just some facts about double and triple bonds. So a double bond occurs when atoms share 2 pairs of electrons, or a total of 4 electrons. It forms only when there is not enough electrons to complete octets. So this was step 4 in our procedure, but I like to emphasize if and only if an octet is not complete, then we can explore double and triple bonds. Y'all love to put double and triple bonds down, but it's a last resort. It's not something we first look to. Triple bonds can also happen. So a triple bond is when they share 3 pairs of electrons or 6 electrons. And same thing here. It's only if an octet is not complete. So an example of a triple bond would be N2. So see if you can do that Lewis structure and get to the triple bond in that one. So the last Lewis structure that I want to talk about in this video before I send you off to go practice is polyatomic ions. So remember, polyatomic ions were these little packages of particles that carried a charge. But if we peek inside the package, so we peel the tape back and we look at what's in the package, what we will notice is that package is held together by covalent bonds. So in this package, I see a hydrogen, I see a carbon, and I see 2 oxygens. All of those are non-metals, so they're covalently bound together. So if I were to write the Lewis structure for this guy, I'm going to follow the same steps. Step 1, determine the total number of valence electrons. So hydrogen is going to bring 1 valence electron. Carbon is going to bring 4 valence electrons. And oxygen is going to bring 6 valence electrons. And what I see here is I have 2 atoms of oxygen. So it's going to bring a total of 12. So 12 plus 4 plus 1 gives me 17. 17 is an odd number. And up until now, all we've talked about is pairs of electrons. So lone pairs, bonding pairs. So having an odd number of electrons is just not going to work. So I must have missed something. What I missed was this charge right here. So what causes charges? The losing or the gaining of electrons. So if this package has a negative charge associated with it, that means this package went out and it stole 1 electron from somewhere. I don't know where, but it's got a negative charge, so it must have got it from somewhere. So if it has stolen an electron, it's added an electron to its package, that means we have to consider this extra electron. So when we are totaling up the valence electrons, we have to consider the charge. So the charge on this ion is a -1. Whoops. That means it's got an extra electron that we need to account for. And now when I total the electrons, I have 18 valence electrons. That's an even number. I can move forward with that. So general rule of thumb is if you total the number of valence electrons and you get an odd number, red flags should go up. Something is missing or your math is wrong. We will not deal with odd numbers. Okay. So same thing here. I've got 18 valence electrons. So let's finish our Lewis structure here. So first step is calculating the total number of valence electrons. Second step is writing the correct skeletal structure. So another just kind of helpful hint that's coming up since we're here, if carbon is in the mix somewhere, he will always be the central atom and the other atoms will be distributed around it. So hydrogen, oxygen, oxygen. Okay. So there's the skeletal structure for this particular Lewis structure. Now I'm going to distribute electrons, filling as many octets as possible. So I always start with bonding pairs and then go from there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I put 18 electrons on the paper. I have no more to put out there, but am I done? No. Carbon has how many electrons? He only has 6. Not happy. I can't put any more electrons on the paper. I don't have any more to give away. So what can I do? I can explore a double bond. So to explore a double bond, I take a lone pair away from somebody that's happy and I throw it into a bonding pair. Doesn't really matter what oxygen you pull from, but I'm going to pull one of these lone pairs from oxygen and I'm going to throw it down into that bond. So just simply moving 2 electrons. Okay. So not a bad idea. Let's make sure that we still have 18 electrons on the paper. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So I still have 18 electrons on the paper. Now let's see if everybody's happy. Hydrogen is happy with a duet. He has 2. He's good. Carbon has 1, 2, 3, 4, 5, 6, 7, 8. So now he's happy. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8. He's happy. And this guy has 1, 2, 3, 4, 5, 6, 7, 8, and he is happy. So here is our Lewis structure for this polyatomic ion. So again, just to review, for polyatomic ions, they are packages that carry a charge. So we need to just identify that charge and add those electrons into the mix when we are doing the total number of valence. From there, all of the other rules stay the same. So that's drawing Lewis structures for covalent compounds.